Liquid-liquid extraction, also known as solvent extraction, is one of the most common techniques used in a chemistry lab in which a compound of interest is extracted from a mixture based on its solubility in two different immiscible liquids. This is usually performed in a separatory funnel. The compound of interest is dissolved in a solution, and a second solution is added to the mixture containing the compound of interest, and the compound of interest is more soluble in the second solution than in the original mixture, so some of it will leave the original mixture and dissolve into the second. The immiscible liquids are usually water and an organic solvent.
Benzoic acid is soluble in both water and methylene chloride because its molecular structure resembles both a polar and nonpolar substance. It's a benzene ring with a carboxyl group. The benzene ring right here is the nonpolar part of the molecule, and the carboxyl group right over here is the polar portion. So the polar portion is more soluble in the aqueous layer, and the benzene ring is more soluble in the organic layer. And that's the aqueous. So it allows benzoic acid to be soluble in both layers. Benzoic acid, however, is more soluble in the organic substance right here, and this is true because the experimentally calculated dissociation constant
During the thing, you can't. Okay?
Kd is the dissociation constant of the desired compound, in which Kd equals X, which we'll call X grams or moles of the desired compound, over the milliliters of the organic substance, in this case methylene chloride, all over the total or initial grams of X minus the grams extracted in the organic layer over the milliliters of water. If Kd is large, then the compound of interest favors or is more soluble in the organic layer. If Kd is large, the compound of interest favors or is more soluble in the organic layer. So more soluble in organic layer if Kd is large. If Kd is small, it is more soluble in the aqueous layer. Its usefulness aids in determining which solution would be more effective in extracting a desired compound.
Single extraction and multiple extraction both use the same amount of solvent, but single extraction uses it all at once, and multiple extraction divides it evenly over several extractions. Multiple extraction is much more efficient at extracting a compound of interest compared to single extraction. The way to tell which one is more efficient at extracting is to see how much of the benzoic acid remains in the aqueous solution. In order to determine how much benzoic acid is still in the aqueous solution, a titration must be done. The less base used in the titration, the less acid that was in the aqueous solution, and the more acid that was removed by the methylene chloride. The single extraction required 13.91 milliliters of base to react with the acid, and the multiple extraction only needed 10.92 milliliters of base. This showed that multiple extraction is the more efficient extraction. To determine the amount of benzoic acid extracted, We first determined the initial amount of benzoic acid in the aqueous solution using stoichiometry, then determined the amount remaining through titration. When you subtract the two, the result is the amount of benzoic acid extracted by the methylene chloride.